So let's continue with the next topic of today's lecture, which is sign extension. So say we want to represent the same number as before, just using more bits. Well, this can be pretty easy for positive numbers, as we could just add leading zeros, but it's a little bit more complicated for negative numbers. And it really does depend on the representation that we are using to interpret this as. For sign and magnitude, we just copy the most significant bit, which is the sign bit, from the smaller number of bits to the larger number of bits, so that's pretty straightforward. And then we just leave the rest of the bits that are the new bits that we have as zeros, and we just copy over the old bits, as normal. For 1's complement and 2's complement, it's actually the exact same thing, and it's fairly simple. We take that most significant bit, and we just copy that to all the new bits that we have that are of the larger size. So some examples are, for sign and magnitude, if we have the value 0b11, we can see that we have a sign of 1 and a magnitude of 1. So if we want to represent this with 4 bits now, we just copy over the sign bit, so now we have a sign bit of 1 right here. And we just pad the new bits that we have as 0, and then we just copy over the old bit here, which is a 1. 1's complement and 2's complement is once again the exact same thing. So we have the value 0b11. If we want to make that 4 bits now, we just take the sign bit, which is a 1, and just copy it over to all the new bits that we have. So we just put 1, 1 here. So that is the difference between 1's and 2's complement versus sign and magnitude when we have to deal with sign extension. So you'll see why later in this course, when we actually get into hardware design, how this is very useful to us.